guys, I need to show you a little something I need to remind you of, and you're going to do some work today on trigonometric functions, sine, cosine, and tangent. You most likely learned about this in Algebra 2 class or Geometry class. Both classes use this idea later on, and then, of course, pre-calc classes. But if you haven't taken all those classes, then you might have a little trouble, or you may not remember. So here's a little refresher. These are just ratios, right? Comparisons of side lengths, really. So the sine of a specific angle, and that angle will be, given to you, and it gives you like your point of view. So the sine is the length of the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and the tangent is the opposite side divided by the adjacent side. And they will end up being decimals that you'll use to multiply or divide to find a missing side. Or you can use the inverse function to find an angle if you have all the sides and you need an angle measure. All right. You're going to see either an angle or you're going to see a label, whether it be like A, B, and C. It depends, all right? But that placement, right? And I'm going to do the same thing here. A, sorry, I'm in my own way here. B and C. And that placement here is important because it's going to say, hey, what is the sine of theta, which is the Greek letter that designates where the angle is, where your point of view is. So when you're viewing from here, this is your angle in question, or angle A. You would know that the opposite side is the side that's directly across from it, all right? And that your adjacent side is right next to it. It's actually sitting, it's touching, that angle is touching that side, right? And then your hypotenuse is always that slanty side across from the right angle. All right, so that's the idea. So if I wanted to talk about the sine of A, I would take the length of this side here, right? And I would divide it by the hypotenuse here. And I'm going to get rid of those because I don't want everything to get all messed up. In this case, because the angle is up here, right? Which side is opposite? Well, it's the side that's way down here across from it. That's the opposite side. And the adjacent side is the leg that helps create that angle with the hypotenuse. Okay, so that's really the idea. So I'm going to leave these trig functions up here, and we're going to go ahead and do some work. And if this is in our way, I'll erase it later. But I want to go ahead and pick up one of the problems that you're going to see on your sheet. What that means is I just have to erase, if I can. Just give me a chance. I'll do that. I'll hit delete. There we go. Now that's not in our way, and I can do some work underneath if I have to. This says find the cosine of C. Well, shoot. The cosine of C, I can't write on this unless I do that. Hey, it still stays up. Perfect. Find the cosine of C. So C is where we're looking from. All right? And we know that the slanty side's the hypotenuse. Right? And the side across from C, that's going to be our opposite side. And the side that helps create the angle with the hypotenuse is our adjacent side. Right? Okay, so now we know. Now we've got this pretty much nailed down. And this says, what is the cosine of C? What is the ratio of the adjacent side over the hypotenuse? And we just take their side lengths. I'll use a different color now. So the cosine of C is going to be equal to the ratio of the adjacent side, and that's 20 units or whatever, over the length of the hypotenuse, which is 29. And that's it. We don't have to simplify it. We don't have to do anything with it. This is all I want you to do right now. Okay? And so we can get rid of this one. And then we'll go ahead and start on this one. And sometimes, oh no, now we have a lot of work. Sometimes we're going to have a problem where one of the side lengths is missing. This is the hypotenuse that's missing. And we're going to have to actually do a little bit of algebra to isolate a variable for us. Oops. Let me get down here and erase that. Hey. Oh, it's poopy. Anyway, let's forget that. All right, let me get out of here. I'm sorry that took me so much time and nothing happened. So let's just go ahead and start working. Sorry, that's messy. Here we go. You have a 38-degree angle, and this is our reference point. And then we have 17, which is our opposite side, right? That's our oppo. And we're looking for the hypotenuse, right? Because that's the slanty side. So what we will write on our paper is, and this is what I want you to do, the sine of 38 degrees, sorry about that, 8, horrible, is going to be equal to 17, that's the length of the opposite side, over our unknown, right? And then we're going to solve for x. Well, how do we get x all by itself? If you don't know this already, there's a little trick. The trick is if you have x in your denominator and it equals something that is just a set value, these two things are interchangeable. I can switch the sine 38 and the x, and that is legal algebraically. I'm going to show you why that works, but it really does work. So I'm going to go ahead and multiply by x to move it to the other side, because that's what I really want to do. I want x over here. So this x cancels out with this denominator x, right? Because you're multiplying by x over 1, and this is 17 over x. The x's cancel out. So I have x times sine 38 is equal to 17. All right, well now, if I want to get x by itself, all I have to do is then divide. So let's go ahead and divide both sides by the sine of 38 degrees. And that cancels out with this guy, and I'm just left with x over here. Now I have x over here, and I have 17 divided by the sine of 38 degrees. And now you see it. I could have just switched the x and the sine of 38 degrees, but I wanted to show it to you algebraically. If you don't have calculators handy, if you're in a room without calculators, don't just run to my room and get calculators. Don't worry about it. This is a valid answer for now. When we have calculators, I'll show you how to do that, because you're going to have to do a lot of this in physics, especially when we have the two-dimensional motion that we're going to get started on. And why do we do this? Because we have something that we're going to make triangular. And I'm going to show you real quick why this is super important. Here's a vector, right? And let's just say, for instance, this is something that has been launched at we'll call this a 35-degree angle. And it's been launched at 50 meters a second. Okay? Well, anything that's launched, Isaac Newton said that it has two components. And remember, when you throw something in the air, once you let go of it, the only thing affecting it is gravity, right? And so its vertical component, the up and down component of this vector, is going to be affected by gravity, right? It goes up and then it comes down, right? So the amount of time in the air depends on how much that up and down motion is affected by gravity. So it has two components. It has a vertical component. There we go. And it also has a horizontal component right there. And so in physics, we just go ahead and create a right triangle. Oops, I left this, oh, beautiful. Who knew? In physics, we just go ahead and do that. And I'm going to put arrows on this. I don't feel like changing color. There we go. Those are our arrows. So we can use trig functions to find the vertical and horizontal components of a vector. All right? And that's why we use these trig functions. Now, getting back to this idea, this is what I want you to finish with on the sheet that we're working on. So I'm going to get rid of all that. And last but not least, sorry, my dog is bothering me while I'm working. She sees the food sitting on the desk next to me and she wants some food. Later. Sit. All right. Sorry, guys. Here we go. Here's the angle. We've been given the hypotenuse, right? Because that's the side that's across from the right angle. We've been given the hypotenuse, and we're looking for the adjacent side, right? Because the adjacent side is the side that creates the angle with the hypotenuse. So if we're looking for the adjacent side and we have the hypotenuse, which of these functions uses both the adjacent and the hypotenuse as the ratio? Well, that's this one. That's cosine. So what I'm going to write here is that the cosine, and I'm sorry I didn't do that with sine, the cosine of 52 degrees is equal to x, that's the adjacent side, right? The adjacent side is unknown, over the hypotenuse. Well, we've been given that 15 as a length for the hypotenuse. And I want to solve for x. Well, how do I get x all by itself when it's being divided by 15? Well, this is super simple. This is some of the easiest math we've done this year, right? So I just multiply both sides by 15. And multiply this by 15 because that's undoing this division. And then I just rewrite this as 15 cosine of 52. And that equals x. And like I said, if you don't have a calculator, you can't type this in there, right? You wouldn't know what the cosine of 52 degrees is. So I'm just going to say, leave it like this. And when we get back together next Monday, I'll help you settle this with a calculator. It's really quite simple. But I want you to be able to do it. So these are the types of problems you're going to have on the sheet. Please go over this a couple of times. Some of you may already know this. If you want to get help from a friend, you go ahead and do that. But that's it. All right. Thanks for your time. Good luck. I'll see you on Monday.